what we can see here are actually two graphs. One, so on the x-axis, you see the ozone doses. So grams of ozone applied per gram DOC. And on the y-axis, you see the ozone exposure and the radical exposure. And these exposures have an impact on the performance and the micropollutant removal. What you see here is that, for example, for 1 gram ozone per gram DOC, for all these different plants, this has actually a complete different ozone exposure. So you apply the same dose to different wastewater samples, and you see a completely different ozone exposure, and you see the same with radicals. So this has a very big impact on the overall performance of your system and on the design of your system. So it's very important to have this water matrix right and to draw the right conclusions from this water matrix. And next to this, water matrices are also dynamic. So this is just with one sample, but yeah, a water matrix is something dynamic and it changes over time. So it's very important to have this in your mind. So that's actually key point number one. The matrix makes the design and operation of such plants very, a big challenge. That's why when we perform virtual piloting with the AMOZONE model, we combine batch test data. So we send 1 or 2 samples to a lab, and we see at the ozone decay, the ozone depletion. We look into this, and we combine this with your dynamic data of your plants. So the flows, the DOC, the ammonia levels. We combine these two together with the process conditions of a future plant. And then we are going to look at what is the optimal dose. What will be your micropollutant removal with different ozone dosages? So the impacts of the dynamics are taken into account. And we also look at the impact on bromate formation. We can look into the aspects of different injection systems. So here we performed actually 9 dosing scenarios in 6 weeks. So yeah, it can really help you to save a lot of time and money instead of doing a real physical pilot.